Hello, my name is Alejandro Santana and this is my Lab3 washing machine implementation. So this is for question 2, which we had to take three inputs and 3 outputs based on a machine washing problem and simplify them into 3 equations. And then, so these are the 3 equations that I got it simplified to. V being the water valve, H being the heater, and then M being the motor. So the motor is on when the temperature of the water is at the right temperature, when the water level is at the correct water level, and when the door is closed. So C is for door being closed, W is for water being at the correct water temperature, and T is for the water being at the correct temperature. So then H stands for the heater is on when the water is not at the right temperature, but it's at the correct water level and the door is closed. And then the valve is on when the door is closed and the water is not at the water level it needs to be. And then we have our truth table right here, and I'll be going over the truth table using the LED and making sure my program circuit into the MXDB is correct. So for the 3 inputs TWC, I used pins E3 for T, E4 for W, and F4 for C. I have my pin planner I can pull up real quick. Yeah, E3 for T, E4 for W, and F4 for C, as you can see on the pin planner. And then the outputs, as we can see, V is M12, H is M11, and M is M10. So on the right side we have V M12, H M11, and then M is M10. So our inputs are all connected to this to the pull-up switch here, and then switches 1, 2, and 3 correspond to inputs T, W, and C respectively. And then the output pins are connected through the resistor and then onto an LED. So the bottom will be V, the one above it will be H, and the third one would be M. So right now we have all switches off, signifying 0, 0, 0. So if we do 0, 0, 1, all none of the, sorry, yeah. So 0, 0, 1 signifies that V is true and everything else is false. So that is correct. Then if we do 0, 1, 0, no, sorry, wrong one. All right, sorry, just gotta get this. Okay, so here we have 0, 1, 0. None of the pins are on. And then if we do 0, 1, 1, sorry, 0, 1, 1, then H is true and the rest are false. And then if we do 1, 1, 0, or 1, 0, 0, sorry, 1, 0, 0, none of the pins are off. All the pins are off. Then 1, 0, 1. Hold on. If we do 1, 0, 1, then V is true. If we do 1, 1, 0, one, 1, 0, then none of the pins are off. And then finally, all true, 1, 1, 1. That means M is on. So yeah, all true, M is true. And yeah, that's the implementation.